Okay, this is section 4.6, number 17. Draining a conical reservoir. Water is flowing at the rate of 50 cubic meters from a conical reservoir, vertex down, of base radius of 45 meters and height 6 meters. How fast is the water level falling when the water is 6 meters deep? And how fast is the radius of the water surface changing at that moment? They want you to give your answer in centimeters per minute, so this is very similar to number 16. So I drew my sketch here. Now this time we do have a set, radius to height, so we can use that ratio to reduce it. So this is my change in volume, and I put it minus negative 50 cubic meters per minute because it's flowing out. And that's going to, help, so the height will be going down negative in the negative direction. So this is why we want to use a negative. Okay, so when h is 5 meters, find dH dt. Okay, so remember volume equals 1/3 base area times height. Volume equals 1/3 pi r squared h. But I'm going to have to take dV dt. I can't take the derivative of this with two variables, so I've got to reduce one of these variables. So I'm going to use the similar triangles as a device. In other words, this right triangle is the radius and the height. And then this smaller one, green, same thing. So these two triangles are similar by angle. They're both right angles and this common angle. So by angle, the little triangle is similar to the large triangle. So you know that, okay, a large radius to small radius, 45 to r, is the same ratio as the large height to the small height, h. So 45 over r is the same thing as 6 over 6, the whole thing over h. Okay, large triangle, small triangle, large triangle, small triangle, because they're similar. Okay, and then I can cross multiply, so I get 45h equals 6r, and then I can solve for r in terms of h. So r equals, if I divide, I got 45 over 6h, and I can reduce this to be by 3, so 3 goes into 45. 15, 3 goes into 6 twice, so 15 over 2h. So now instead of writing r squared, I'll write 15 over 2h squared. So I've got everything in terms of one variable. Well, actually, yeah, one unknown. Actually, two. So we're going to take our derivative implicitly. We'll be in pretty good shape. Let's simplify this first. So 15 squared is 225, 2 squared is 4. And then 3 happens to go in, and that's going to be h squared times h. 3 goes into 225 75 times. So this is my simplified form. Volume equals 75 over 4 pi h cubed. So now I'll take the derivative of both sides implicitly. Okay. So dV dt, again, we're taking the derivative of both sides with respect to t, time. So dV dt equals 75 fourths pi. This is all constant. 75 over 4 pi, and the derivative of h cubed is what? 3h squared dH dt. And then 3 times 75 is 225 over 4, h squared dH dt. Now I can substitute my known values. So this is going to be negative 50. The dV dt is negative 50. Remember up here, dV dt is negative 50. And I got, again, my constant 225 over 4 pi, and h is 5, so that's 5 squared. dH dt is what I'm looking for. Okay. Okay, so I can solve for dH dt. So dH dt will equal, and then I can multiply 4 times that. So I've got negative 50 by 4. And I'm going to divide that by 25 pi times 25. So this is dH dt. dH dt. In other words, I multiply, so this actually is going to skip over here, so I'm looking at this. So multiply 4 times this, that's going to give me the top, and I divide by this, so that goes on the bottom. And that's going to give me dH dt. I hope you can follow that. Okay, and then 25 goes into 50 twice, 2 times 4 is 8, so I've got negative 8 all over 225 pi. Now that's meters per minute, but I want it in centimeters per minute. So I have to multiply by 100 centimeters per meter. The meters cancel. So I've got 8 times 100 is 800 over 225 pi centimeters per minute. Okay, so that's my dH dt. And then I can divide the top and the bottom by I can reduce this, what goes in there, 16, 3. I can reduce this by 25. Okay, 25 goes into 800. Every 100 there's got 4 quarters, so 4 times 8 is 32, so there's 32 quarters in 800, or 32, and there's $2.25, there's 9 quarters. So I can reduce the top and the bottom by 25. So I get negative 32 over 9 pi centimeters per minute, and that rounds off to be approximately 1.13 centimeters per minute. Okay, now we want to find dr dt, and again, like in problem number 16, we already have this relationship. We know that r from up here, where the heck is that critter over there? Oh, over here. We know that r equals 15 over 2h. So since r equals 15 halves h, if I take the derivative of both sides of this little mini equation over here, this nice easy one, I get dr dt equals 15 over 2 dH dt. But what was dH dt? dH dt was the negative 32 over 9 pi centimeters per minute. And I kind of canceled over here. 2 goes into 32 16 times. 3 goes into 9 3 times, and into 15 5. So I got 5 times 16 is 80, and 3 pi. So I have negative 80 over 3 pi centimeters per minute. And that's going to be approximately, if we round it off or divide it, it's going to be approximately negative 8.49 centimeters per minute. Okay? Oh, I forgot my negative sign over here, pardon me. That also should be negative, because as I'm draining water out of the tank, the water level is decreasing, and so is the radius. So this would be the water level, and this is the radius. Okay? All right. So if that helps.